In this video, we will be getting an introduction to SCADA. We will understand what SCADA is and what are its uses in the industry, its application, and all this we will get to learn in this lecture. So let's start. So, if you are a student and are preparing to become a SCADA engineer, then this course is going to be very helpful for you, as this would make it easier for you to get a position as an SCADA engineer. So let's start this journey and learn about SCADA. A question: what is SCADA? It is an acronym for Supervisory Control and Data Acquisition. From this full form, we can make out that through this SCADA, we can supervise, acquire, and control the data. Now, what kind of data can we control through SCADA? We can control the plant controller that is installed to control the machinery in an automation industry, like PLC. Also, to supervise all the data from these controllers, we use SCADA. In this, the SCADA will be collecting, acquiring, and supervising all. We can also control it. Okay, got it? Now, SCADA is a completely software-based approach which presents our plant in an animated way, where all the inputs and outputs of the plants and all the operations under progress are represented in real time. There are a lot of different kinds of symbols which can be created using animations in SCADA, like motors, lamps, or alarms. With the help of SCADA, you can easily check if a particular motor is functioning properly or not in the plant from the comfort of your office. Along with that, the switches can be accessed in the system to operate the motors if needed. We can control the inputs and outputs while sitting in the control room through SCADA. Okay, so two functions can be performed through SCADA, that are supervision and controlling. There are a lot of companies which provide SCADA to the market under different names. There are a lot of brands that develop SCADA. Like for Wonderware, the SCADA system is known as InTouch. Another one is Allen Bradley, which is owned by Rockwell Automation and has a SCADA software name RS View. One company which has 50% share of the controller market, that is Siemens, has WinCC as their SCADA software. GE Fanuc is another company which has a SCADA known as Simplicity. So different companies have named their SCADA software under different names. Now, we have one advantage for using the SCADA by Wonderware, which is called InTouch, as it can function with a wide variety of controllers of any brands, unlike other systems such as Siemens WinCC, which require a controller from Siemens to function. Similarly, Simplicity will not communicate with GE Fanuc. If you have RS View, it will only connect with Allen Bradley controllers. But through InTouch, we can get the benefit of connecting it with any brand's PLC. We can communicate and configure too. This means that we can supervise the data from various different PLCs, and in the industries, Wonderware's InTouch is widely used. Hence, in this course, we will learn about InTouch. Moving forward, there are a lot of different packages that are available for SCADA based on different requirements. The smallest package of them all is a factory suite, which is a basic package. It only has files to run the SCADA. So for example, if someone has developed a SCADA file, then we will only be able to run that file. One cannot edit or develop. Also, it won't be possible to connect it with any PLC. So the factory suite is just there to run the files and to check if the animations are working properly. But the networking, that is communication with any hardware, is not possible here. Hence, neither can we add or edit, neither can we remove nor make any changes in the animations. The second package that is available to us is called RN, which is runtime and networking, which means that runtime and networking is available in the RN package. Runtime means that the files that have been developed in SCADA and provided to you can be viewed and also can run. Along with that, you can also integrate and connect that file with a PLC and can easily operate, control, and supervise it with the help of RN package. But there is one downside of this package, and that is development. The development of the files is not possible with the RN package. You cannot edit or create any new animations in this package that have been previously developed by someone. So the limitations of the RN package comes in at the development, but still it is able to do runtime and networking. There is one complete package that is available to you, which is called DRN, which includes development, runtime and networking. Everything is available in this package. Development is possible in this package where animations can be made in SCADA. The input and output animations can be presented of the things that are happening in the plant. As well as when you go in the runtime, you can check how your animation is running. The last thing, that is networking, is already there, which allow you to connect to the PLCs of the plant. So DRN is a complete package where we can create, run and supervise. The SCADA that we will be looking at is DRN, where we will be able to do development, networking and also runtime about how an application is made. Now, the communication flow or data flow of a plant is shown here. Firstly, all the instruments of the plants are known as field instruments. What are the things included in the field instruments? It includes sensors that are measuring and controlling the PV, which stands for process variable. These sensors are installed in the field where the processes are undergoing. Now, these sensors where the processes are running are known as field instruments. These field instruments sense the PV and provide us with the data. The data is then transferred as an input for the controller. The controller is the PLC which has been installed, and whatever data is being collected is being sent to the PLC. Okay? Now, in which form is the data being retrieved? Let's take an example of a sensor. Let's take an RTD sensor. This RTD sensor is sensing the temperature, the heat, but what output will it give? It would not be transferring or sending the heat to the controller. Then what will it do? Because if the sensor starts to transfer the heat, then controller could burn, right? So it won't be transferring the heat. It converts the heat as the sensor is RTD. So there would be change in its resistance. So according to the resistance, it would be giving voltage and current. Thereby, the data of the sensor would be in form of the electricity as current or voltage. If it is in the form of current, then it has a range of 4 to 20 milliamps. Or if it is in the form of voltage, then its range would be in between 0 to 10 volts. Okay? Now, where is the output of the sensor going? It is going to the controller, which means in a PLC. All the data that we got from the field instrument went to the PLC in the form of input for it. Here, if you want to supervise the data that the PLC is getting, then we need a SCADA system. With the help of SCADA system, we would be able to supervise the data from the field. Along with that, as you can see here, the communication is two-way. The data from the field instruments are going to the PLC, which in turn is going to SCADA. Then we are able to monitor it. And hand in hand, we are able to control everything. If you give any command through SCADA, if you turn on any switch, then where is the data first being sent to? It would first be sent to PLC, which is a hardware. As the data is going to the PLC, so it would become an input for the PLC. According to that, we create a program and the program would be executed and output will be generated. So this is how your communication flow is occurring. We are taking the data from the instruments and supervising it in the SCADA. Then we are sending the data from SCADA to the PLC, which is the hardware, and ultimately generating an output according to it. which means that whatever instruments are in our plant are being operated from the control room with the help of SCADA. There are a lot of benefits of the SCADA. We are able to supervise the activities that are going on in the plant, and along with that, we are also able to control the same activities from the same place. There are a lot of features of SCADA. We will look at each one of them one by one. The first feature that we can see here is dynamic graphic of process. In here, whichever process is running can be presented in a graphical manner with dynamic graphics. To visualize, if you have a bottle filling plant, then what will happen in the plant? There would be a conveyor belt system where your bottles would be moving. The bottles would be getting filled. Okay? Now, there would be a tank that is filling the bottles. That tank would be emptying slowly as it is filling the bottles, one by one. All these processes can be seen live in SCADA. We can see how many bottles have been filled or how much a bottle is filled, what percentage of the tank is filled or empty. So, this was dynamic graphics of processes, where we can see our processes dynamically, which means in an animated way. The next feature that we can see here is the trend. What is the trend? Trend in SCADA is representation of all the data in a graphical manner and in graphs. There are two types of trends available in the feature. The first one is real-time trend and the second one is called historical trend. As you can guess by the names here, real-time trend would be providing the value which is real-time, which is live for any particular processes. This live value, which is in real time, would be monitored in a graphical way through real-time trends. Okay? All the processes underway, how many bottles are filled, will be shown live in real-time trends. So, the real conditions, the present value of the process would be shown in the real-time trend. That too in a graphical way. The second one is historical trend. What happens in historical trend? All the data of the processes that have been stored in the application could be viewed in historical trend. In there, we would be able to store the data and would be able to view and monitor the data on any particular date or time. That on a certain date or time, what was the value of the process or what was the data of that process. All that data could be viewed easily in the historical trend, that too in a graphical manner. So, these two are the functions of the trend, where in real time, we would be able to see the present value, and in historical, we would be able to see the saved data of any particular time. Now, the next feature that we can see is alarms. When do we require alarm? When do we use alarms? There are different kinds of situations where we need different types of alarms. Like in case of a fault, then I would need an alarm, or in a case when your water tank is completely filled, at that time I would need an alarm for indicating to me that the tank is full so that I can turn the motor off. I can also set it to automatically turn off through the controller. At that instant, I would need to generate an alarm. Along with that, whenever my tank is empty, at that time I would also need an alarm. Or in a different scenario, where we assume that there is a process undergoing that is generating some heat and we need to control the temperature. So, in case if the temperature exceeds the set limit, then I would need an alarm. Whatever the flow of the process variable, if the flow increases, then at that time I would need an alarm. In all the process variables, if they deviate from a set point or when we need an indication for a certain point, we would need an alarm for the indications. Okay, clear? Now, there are many different kinds of alarms like value alarm, deviation alarm and rate of change. We will see in detail how these alarms are created and how these alarms would be used. The value alarm is related to a particular value or a range. For example, in our case of the water tank, when the water tank is being filled and if the tank is filled up to 90%, then I would need an alarm. So, whenever the level of the tank is more than 90%, an alarm would be generated and I would see an alarm. This alarm that is generated, we call it value alarm. When anything exceeds the particular value, then it is called a value alarm. The second alarm is called deviation alarm. It is related to the fluctuations. For example, if the set point is 50, then we can set a fixed percentage that if deviates over or below the certain point, we should get an alarm. Now, how much deviation do we need for the alarm to go off? Let's take an example. For the set value of 50%, we would be able to set two different kinds of alarms, that are minor deviation and major deviation. If you set a value for the major deviation of 10, then what will happen is, whenever your value will rise above or dip below the set value of 10%, then an alarm would be generated and you would be able to see an alarm. So if 50 is the set point value and our range is from 0 to 100, and we set a deviation of 10%, then whenever the value reaches 40 or 60, which is 10 below and 10 above, we would get to see an alarm. Furthermore, security. What is security? To secure anything, here in SCADA, as it has many different features, so many different windows can be made in SCADA. Whenever we develop SCADA in a plant, we never keep everything in a single window. Some data we need only for monitoring purposes, and also there is some data that we need for controlling purposes. Okay, so for everything a new window is made. For a window that is there just to be monitored, and I only have to supervise, so supervising authority would be given only to the supervisor. But whenever we want to do operations and whenever there are options for control, not everyone can operate it. Only the authorized individuals like the SCADA engineers are the only ones who can operate it. So to prevent everyone from accessing everything, we provide and enable security. Now let's assume that everyone can access it and there are some visitors coming to our plant and they saw a SCADA system and they operated a switch from it. Then what will happen is, a motor might get turned on which should have been off, or a motor might get turned off when it should have been on, and all of our processes would stop. So to prevent everyone from accessing everything, we provide security for it. How can we provide this security? We can provide it by giving user ID and password to the individuals that are needed to access a particular window. Simple. Just like in our systems, we can do the same in SCADA with user ID and password and provide access to different windows to different people by using ID and password. How a user ID and password is created will be shown in the further lectures on security. Next feature that SCADA provides is recipe management. What is recipe management? What is a recipe? The name recipe indicates that mixing of different kinds of ingredients to make a distinct recipe or make a particular material through particular methods and recipes or different ingredients in different quantities that helps you in making final product of different kinds. This thing is particularly used in pharma and medical industry and it is used widely there. The medicines that are made there are made of different ingredients in different quantities, and after mixing it all, a final medicine is produced. A final product is produced. So whenever there is a requirement of mixing different kinds of ingredients for production of different kinds of final products, the recipe management feature is used. We will also be learning about how different kinds of recipes are made and created in SCADA, and also how to load those recipes. We will learn about it all. Device connectivity. It is one of another feature. What is device connectivity? As we have seen, SCADA supervisory control has a feature of data acquisition, which means not only we can supervise it, but also control it. In order for SCADA to control those things, it has to communicate with the hardware and all the different kinds of devices. Okay, so we will connect this SCADA and to do the networking and then operate our plant with the help of this SCADA. So this was device connectivity. In the InTouch Manager, when you open the software, you will be able to see two windows. Which ones? The first one is window viewer, which is also called runtime environment. And the second one is window maker, which is called development environment. In the window maker, we will be developing all the animations of the plant in SCADA. It can be called development environment or development window or window maker. You can call it any of these things. All the animations that we would be creating or making in SCADA will be done in the development environment or window maker. Then whatever we have developed as different kinds of animations, we can run in window viewer or runtime environment. In there, we can check for how our animations is running and how it looks. And in case we want to see the live animation of the plant, we can also see that in window viewer.